Good afternoon, good morning, actually. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT and Global Knowledge Research Foundation. As every one of us is passing through unseen circumstances due to COVID-19, we wish everyone and their families a safe time, and we all will together pass this soon. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference, and the papers will publish in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for the conference in these unpredictable times, and we make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of the knowledgeful and interactive sessions. I would like to welcome you to the technical session number 5 and further introduce you all to the chair of this session, Professor Saurabh Singh. Now, Saurabh Singh currently joined assistant professors at Dunkirk University, Seoul, South Korea. Previously, he did his postdoc from Konsan National University in South Korea. He got a PhD degree from Chonbuk National University, carrying out his research in the field of ubiquitous security. He holds a strong academic record. He received his bachelor's degree from Uttar Pradesh Technical University and holds a master's degree in information security from Tapar University. His research interests include cloud security, IoT, and cryptography. He has experience of being a lab leader. Saurabh Singh is the reviewer of IEEE IoT, IJCS, IEEE Access, and FGCS, Journal of Supercomputing, IJDSN, and Compellicing, and many other journals. He has published many SCI journals and conference papers and received the Best Paper Award in KIPS and CUTE Conference 2016. Welcome, Saurabh Singh. Okay, so Professor is not here.
I think, Basil, you can start with the session, and I think Dr. Saurabh just joined and he went back, but he will be joining soon.
Okay.
So with the presenter, you can just start with the session.
So for our next presenter, Libero Negro, presenting performance comparison of 2 Java-based actor systems.
Okay, thank you.
The
I
floor
try
is yours.
to share my screen.
Yes. The floor is yours, and you have 12 minutes.
Is this visible?
Not yet, no.
Not yet.
Now?
Yes, it is.
Yes.
Yes. Okay. Thank you for the introduction. My name is Libero Negro from University of Calabria, Italy, and I will talk about a work in which we have experimented the execution performance of 2 actor-based systems in Java. And the 2 actor systems are akka, which is a well-known actor system which is implemented in both Java and also Scala. And akka is mainly an implementation of a classical actor a la Gulaga, and akka is directed to untimed concurrent distributed systems. The importance of akka is that is testified by considering that it is used actually, for example, by some major companies like Intel, Twitter, etc. And akka is efficient because it associates dynamically a thread with actors, but only when actors have messages to process, okay? And this is the core key concept of ACCA, which contribute to its execution performance. The second actor system, which is compared with ACCA, is our own actor system, which is developed by our research group, and is named Theatre. Now, Theatre is a particular implementation of actors because it is designed with a key concept as the core concept, which is based on control. In theatre, scheduling and dispatching of messages are part of a reflective control layer, which regulate message scheduling exactly, and also it regulated dispatching. It is also possible for theatre to work with the deterministic strategy, which we are in this time are developing, addressing cyber physical system. So a major difference between theatre and ACCA is that theatre is addressing time-dependent distributed system like a cyber physical system, but theatre can also be used for high-performance computing. Differently from ACCA, actors are not provided of a thread and have no mailbox. Message buffering and dispatching is, I repeat, the responsibility of the control layer of each theatre. This is a picture which gives a snapshot of a particular theatre implementation on multi-core machine, which we call parallel theatre. And as you see, an application is split in multiple theatres, and each theatre hosts a collection of application actors, and it is governed by a control layer instance, and it also has a transport layer, which is used for interfacing this theatre with the remaining theatre of the application. What is important to stress is that there is one thread for each theatre, but each single actor which executed within a theatre is not provided of a thread and runs cooperatively using only message interleaving. Okay. Now, this is just to give you a flavor of the programming style with the theatre actors in Java and also actor using the ACCA language. And as you see, there is a very similarity because ultimately, in each actor, there are some message servers methods which process specific messages. Okay, now to give you a flavor of the execution performance of ACCA and Theatre, we have chosen a particular benchmark, which is challenging because it is scalable, and it was chosen because they iterated the prisoner dilemma benchmark. It was chosen because it allows to study the emergence of cooperation in very large population of players, for example, hundreds, thousands actors. So this application is time-stepped and it is organized into manager and players, okay? And the execution goes on by subsequent period. At each period, the manager asks a player to engage a standard prisoner dilemma game with 4 neighbors, which can be statically defined in a persistent structure neighborhood or dynamically established before each period. And the payoff earned by each player is accumulated and averaged over the 4 neighbors. At each period, the manager first asks its player to do a PV game, please. Then awaits done messages by local players, and after that, manager asks a player to adapt their behavior according to neighbors' behavior. Finally, players send a done message to their manager. So there is a lot of messages which are exchanged during the operation of the model. Okay, for statistical coherence with the standalone model, which we also developed to validate the parallel version of iterated prisoner dilemma, for statistical coherence, it is important that a sub-block of players which are assigned to a given manager have to share a same pseudo-random generator. But it was not easy to transform the theater model of iterated prisoner dilemma into H, because H have not the structure of theater, in the sense that it is not a federated system which the user in the end realizes, but all the actors are independent. So for example, there was a problem when trying to reproduce also in H that a sub-territory of players have to use the same random generator. It was not immediately possible to use a common generator in a given region, because this would have been to use in H some form of locking, and this would be prohibitive for performance. In H, we use a split table random, which almost reproduce a one-sharded random generator for manager region. Instead, in theater, there are no problems in sharing data, some shared data in a given theater, because in a given theater we use a cooperative concurrency, and so in any case only one actor at a time can be in execution. So there is no need to use locks, etc. And so in theater it was more easy to reproduce the model. And as a first concern, we tried to compare the functional level of our model with the standalone monocore implementation. And as you see, we, for example, observed, and so we retrieved the same result when a persistent structure, in a sense, each player interacts with always the same neighborhood. In this case, it is possible to observe the cooperation ultimately emerges from the model, and cooperation is seen here, where the fitting value is more close to 3 than to 1. When the fitting value, the payoff value, fitting value tends more to 1, it is the defection which emerges during the execution. So first of all, we checked the correctness of the parallel implementation model of the iterated prisoner dilemma, and we were assured that we reproduce statistically the same behavior observed on a single machine. Now about the experimental analysis which we realized in practically. We used a population of n per n matrix of players, and you see that we allow to grow the dimension n from 16 to 512. So we have a lot of players which are involved, and we measured the execution time in milliseconds required to finish the execution, which is comprised of 3,000 periods in the time-stepped execution. And we can see that even in the base case in which we compare H and theatre, we have some speed up of theatre with respect to H. But it is a moderate speed up because in our implementation, we use the machine which is a quad-core machine. So the theatre implementation exploits exactly 4 theatres, 4 threads. But the ARC implementation is able also to exploit the hyperthreading feature of the machine. And so, in any case, we run better than AK, but with a limited speed up. You see that when the dimension is 128, we have a speed up of about less than 2. But as another experience we have realized, we designed also an optimal organization of the theater model. And the optimal model in theater minimizes the number of exchanged messages among players and then manager. In this case, we use a shared counter. Using a shared counter is not a problem in theater because within, I repeat, each theater, we don't have threads. We have only cooperative concurrency. So in this case, we count the number of players which completes their activity, and only when the last player finds it is the last one, it sends just one done message to the corresponding manager. Such a solution cannot be adopted in Akka because in Akka, using a shared counter among a group of actors would imply necessarily the use of locks. So in this case, this optimized version of a theatre, as you see, in this case, the speed up is even better, and with a dimension of 128 dimension of the matrix of the population of players actor, we achieve about 2.5 as a speed up on a machine with quad cores, okay? Now, I go to conclusion because obviously I can't go into much detail about the technicality for the few time which we can use. And I would stress that theater is designed mainly for cyber-physical system. But theater can also exploit it for a performance computing, as I have tried to show you. And we have shown that through the challenging, scalable, parallel iterated prisoner dilemma model, we have observed a better execution performance with respect to AK. And please consider that AK is felt as one of the most efficient actor system we have today among the various implementation. So the results, the experimental result confirm that the theatre is able to deliver very good performance, even better than achievable by AK, and this is encouraging and promising. In this moment, we are engaged also continuing improving the runtime organization of theatre, possibly porting theatre to other language. In this moment, we use the Java, as I have explained it. Other target language can be Python, Rust, etc. But our main work in this moment is completing deterministic theatre for cyber-physical system. Now, I have finished, and thank you for your attention. And if there are questions, I'm here. Thank you again.
Thank you, Professor, for your presentation. You have 3 minutes for any questions. Sorry, yes.
Hi, Dr. Libro. I think you are done with your presentation.
Yes.
Yes.
Okay. I think our chair is having some issues in joining the session, so I really thank you for your presentation.
Thank you.
In the audience, is anybody having any questions?
Questions?
I think Basil, then we can move on to the next presentation.
Sir,
And
my
Okay.
paper ID 127.
okay,
Yeah, our next presenter, I'm gonna share my screen, is Ravi Ranjan Kumar, Harmonic Compensation Strategy for Increasing the Operating Range of Solar-Fed Single-Phase Cascaded H-Bridge Multi-Level Inverter. The floor is yours. You have 12 minutes, sorry, to present.
go ahead, Mr. Ravi. Yeah.
Hello, sir. Myself Ravi Ranjan Kumar. I am from India. My paper ID is 127. The title of paper: Harmonic Compensation Strategy for Increasing the Operating Range of Single-Phase Cascaded H-Bridge Photovoltaic Multi-Level Inverter. This is the table of contents in introductions, objectives, modeling, simulation analysis, and results, conclusion, references. First of all, introduction. Multi-level inverters are continuously receiving more and more attention because of high voltage operation capability, high efficiency, low switching losses, low output of electromagnetic interferences. It is the arrangement of power switching devices and capacitors voltage sources. It attains a high voltage with limited maximum device ratings. What is the need of cascaded inverter? Because already there are many inverter like flying capacitor, diode clamp. Here the cascaded inverter it drawn tremendous interest due to greater demand of medium voltage high power inverters, and it requires a number of isolated DC supply, each of which fits an edge bridge cell. The benefit of cascaded inverter: for less number of switches and devices, it got same level of inverter as compared to the flying capacitance and diode clamp-like inverters. So this is the objective. First objective is mathematical modeling of control strategy, and second is the perform simulation of cascaded H-bridge photovoltaic inverter. Here, my method is harmonic compensation strategy. Its principle, the harmonic compensation strategy inject a certain harmonic into the modulation waveform of over-modulation cell. And to make the grid current not contain the injected harmonic, the modulation waveforms of normal cell need to compensate harmonic, which fails just opposite to the injected harmonic in over-modulation cell or higher power cell. That's the harmonic components get cancelled and only the fundamental in phase component of sinusoidal remains in the grid current. This is the block diagram. I have taken two S-bridge inverter and I will connect as a cascaded. Here I have used SPWM, sinusoidal pulse width modulation. In the reference is taken as sinusoidal, where the carrier signal is taken as triangular waveform. Already there are three types of SPWM: in phase disposition, phase opposition, and alternate phase opposition disposition. I have designing, there are components used to design IPDPWM. This is the switching table of 5-level cascaded S-bridge inverter. Here I am going to discuss IPDPWM use. In IPDPWM method, all carrier signal above and below reference lines are in same phase. This is the frequency modulation index, amplitude modulation index. These all are data I have used. Here, single phase S bridge PV multi-level inverter connected to the grid. This is the photovoltaic module. The output of photovoltaic module is give as individually S bridge multi-level inverters. Here the problem is due to a randomly variation of temperature and irradiance, the output voltage of power module is changes. So it's cause the overmodulation and the harmonic induced in the grid current. This the components used in control block diagram of single phase CHV PV inverter. I have used this component like PV photovoltaic maximum power point tracker, cascaded boost converter, phase lock loop. This is the basic circuit diagram of photovoltaic system. This is the PV array or PV panel. Here, link collection of photovoltaic module. Each module is made of multiple interconnected PV cells. The cell converts solar energy into direct current electricity. PV modules are sometimes called as PV solar panels. Here, this is the diagram. This is the cell. Here, module is consist of many cells. Here, the PV array is consist of module. This is the mathematical equation. The current generated from the PV array is directly proportional to the solar radiation. And this is the sun current. These are mathematical equations. This is the reverse saturation current, temperature equivalent. Here, with a different solar radiation, the characteristics of current and voltage. And this is the characteristic of power and voltage. Here, I have fixed the temperature 25 degrees Celsius, but radiation is the varying 200, 800, 1000. Here, the effect so current is varying in largely, but voltage is almost very less. We can say the current is dominant of the solar irradiation. And this is the power voltage characteristic with variation of irradiation. And at different temperature, the current is almost very small variation, but here the voltage is very largely, like this 5, 25, 45. Temperature is increasing, the voltage will be reducing. Here I have used the maximum power point tracker. Maximum power point tracker, it optimize the voltage and current and provide the maximum power point. Here duty ratio value 0 to 1. I have optimized the duty ratio of promised I use 0.85 in boost converter. This is the characteristic of maximum power point of PV array. This is the optimum voltage, and this is the optimum current. Here we can got optimum power. Here the basic concept of boost converter, DC-DC power converter, which step voltage from input to output. We can optimize the voltage as per requirement. This is the class of switch mode power supply trending. This is the two semiconductor switch. To reduce the voltage level, filter made of capacitors are normally added to such a converter output low side filter and input supply side filter. This is the step of chopper. The output voltage is achieved by fast switching the devices. Here I have designed the controller. This is the S bridge controller, and this is the master controller or slab controller. Here name is master controller or slab controller because its input depends upon the S bridge controller. Here the current is generated ID S bridge controller is fed to the master control or select controller. It compare and generate the here amplitude voltage and the theta between the amplitude voltage and grid voltage. Here we can generate the Vm sin omega t minus theta. The optimum pulse generator. This is the closed loop control system, and we fed the sinusoidal pulse with modulation. This is the pulse. This is the all mathematical equation. The amplitude of total modulation voltage and phase angle between total modulation. Here, theta angle between the grid voltage and amplitude voltage. And this is the modulation waveform. Here, injected harmonic SPI. into the modulation buffer, the total harmonic. These all are mathematical equations. This is the first I have connected the grid by the output of the inverter circuit. And second case, I have connected the RL load. This is the this is the output buffer. I have connected the grid, and this is the grid current. This is the grid voltage. If without use simulation is done without using a control system. Then after the using the control system, here the grid current is vary increasing from 5 ampere to 6.5 ampere. In second case, I have connected the RL load. So output we got 5-level multi-level inverter. This is the input. Then after using the control system, the grid load current will be also increasing 5.2 ampere to 6.9 ampere. And the after using the control system, the voltage also voltage buffer also close near to the sinusoidal buffer. Here, the effective analysis of grid current without controller. The without controller, the total harmonic distortion 11.01%. But after using control system, the effective analysis of grid current with controller, the TIT reduces 3.14%. Conclusion. In this paper, I presented an analysis and simulation of single-phase cascaded S-bridge photovoltaic multi-level inverter. The system is used to eliminate harmonic present in grid current and extend the operating range of cascaded S-bridge PV grid inverter. The simulation results show that the range of grid current is increasing from 5 ampere to 6.5 ampere after harmonic compensation strategy-based control system. And TIT is also reducing from 11.01% to 3.14%. This is the references. Thank you.
Thank you for your presentation.
Yes.
You have 3 minutes for any questions. Any questions?
Any questions by the audience?
Yes, sir.
Okay. I think there are no questions. Professor Negro, do you want to ask any questions? Okay.
No.
Fine. Thank you very much, Mr. Ravi. And
Thank you, sir.
Move on to the next presenter.
Okay, thank you, sir.
So our next presenter is Fikri Nusser, presenting WSPDC, Persistent Distributed Channels-Based Web Services applied on IFRS data processing and loading. The floor is yours. You have 12 minutes to present.
Yes, thank you. So, hello everyone. It's a great pleasure to be with you in ICICT. So, my paper is about web service and persistent distributed channels. So, my team is composed of 5 members. So, it's me, Mohamed Rida, Nourdin Abor, Khalid Moussaad, and Amin Al Omri. Firstly, the plan of this presentation is an introduction. So I'm going to introduce you to Stadiat problematic. Then talk a little bit about classic business intelligence.
I'm sorry to interrupt, but you didn't share anything. There's no presentation.
Okay.
Okay.
Just 1 minute,
Let's
please.
see.
Now.
Okay, yeah. Now we can see everything.
Okay. So then I'm going to talk about a little bit about classic business intelligence. After that, the integration of Apache Spark and its concept in big data processing. After that, the persistent distributed channels and reporting EFS driven data, then web services concept, and finally our approach. So as an introduction, so IFRS stands for International Financial Reporting Standards. It's it's a set of standard rules that are mandatory to produce reports. IFRS data must follow normalized meta model. It's the main model to follow for reporting financial data. To produce this data, there is several calculations on information system, especially on financial data issued from data marts. There is another standard, which is the GAP used by USA and a few other countries. The GAP stands for Generally Accepted Accounting Principles. To produce this kind of reports, we need to extract data from production databases. Functionally, we call them subledgers. So we submit this data to several transformations, such as calculations, aggregations, deduplications, and other transformations. The problem of this kind of processing is that it's a scheduled availability of data warehouses. So we need a new concept such as distributed data processing, which we're going to see that in Apache Spark resilient distributed datasets concept. Then presents a new concept that we have published in another paper, that is persistent distributed channels and web services for ready-to-use data requests and responses. So let's talk a little bit about classic business intelligence. So ETL stands for extract, transform, and load, and it's a very old concept. So it consists of extraction from information systems database, flat files, or other data sources, then submitted to a group of transformations that are in form of jobs which are scheduled and executed outside the working hours. Then after that, we load the resulted data to specific data mart or targeted data warehouse, which is a centralized database ready for use by reporting and analysis tool. So we can see the schema here. It's an extraction from a database. Then we transform this data and load it in a data warehouse. So for what is the big data and the use of Apache Spark in it. So big data is the most coveted area of research in the last decade, with main challenge of enhancing large amounts of data processing by using optimized pipelines and algorithms. So after Hadoop, I think that all knows what is Hadoop. It's the most used tools for big data processing. Then after that, there is an emerging technology that solved data processing speed and memory problems. It's Apache Spark, and it uses a new concept of resilient distributed data sets. And it is based on last recently used algorithm to manage data between memory and disk, to save it and holding it in memory for a quick access. So what is persistent distributed data channels? Distributed channels. We have two languages, Java and Scala, which are compiled and transformed to bytecode and interpreted by Java Virtual Machine. And we have Python, which is directly interpreted by its interpreter. And we have near metal languages such as C and C++. There is a new language that use the same concept of C and C++. It's Golang, and it's an optimized language for hardware resources optimization. It is based on an old concept, communication sequential processes that use instead of communicate by sharing memory. Golang share memory by communication. It's a reverse process, and it has already proved its performance. And persistent distributed channels used also the last recent used algorithm for data storage between memory and disk. We go from resilient distributed data sets to persistent distributed channels to avoid GVM problems, and also to have a program that is directly executed in our machines. What is IFRS data? So in each company there is an information system called general ledger, from which its name, this ledger summarizes all financial activities of an enterprise. We need to extract from these ledgers statements, which are financial reports, but we need to follow a structured meta model, which is the chart of accounts defined in IFRS standards. So all financial details are structured following COA, chart of accounts, in order to emphasize segments by business units and cost centers. So the main purpose of using this chart of accounts is to avoid the misunderstanding of metadata. So it's the main purpose. After that, we use the web services concept. So the main purpose of using this concept is data publishing and simplify its access by request response. There are two types of web services: REST, which stands for representational state transfer, and SOAP, which is simple object access protocol. Then a known protocol, which is HTTP. So REST servers use HTTP protocol by using get, post, put, and delete requests. And SOAP use XML messaging over sockets. So it's not a specific port, but it can be any port on our machine. And REST servers use WADL, which stands for Web Application Description Language. However, SOAP server uses web service description language. So now I'm going to introduce you to our approach. So our approach is a new architecture for data processing. So it's composed of main service which handle a master instance. So the blank squares below master is our data at its initial stage, and after distribution on workers, they are considered as persistent distributed channels. Each routine has its sets of data which are fault tolerant um, data by making it by making a replicate on disk, and it is handled also by more memory by using LRU algorithm. In this figure we have it's an example. We have 4 routines. That means 4 channel of data stored in memory and 1 routine on disk data. So the persistent distributed channels web service have a main web service which is requested with the following parameters: the targeted data sources and its transformations, and the 2 of them are submitted to this main web services as HTTP post request. Then we have 1 or more PDC workers as web services that can be requested separately, depending on data mart, which stands of subject orientation, with the following parameters. So the first parameter is the server on which are deployed our web service or a worker web service. Then the requested data mart for subject orientation, the requested dimensions, and for each dimension the requested attributes. So we have here a request example on JSON format. So we have an input, the worker, which is a data mart, which is subject oriented, local host account payable. It's on our local machine. A data store that's called temp, and the data sources. We have 1 data source, which is a supplier. Its type is database, and it have its database type. Then the authentication IDs.
Sorry
We
to
have
interrupt, but you still have 2 minutes.
okay.
Yeah.
I'm already done. So we have also the input request, which is in form of instruction. So the instruction store is temp, and the instructions is instruction 0. The type of this instruction is joining, and the first constraint is no replicate. So it stands for no replication of data. Then the data source from which data comes, then the data to retrieve, which are supplier 0, 1, and 2, and the output is the PDC web service 0. So we can retrieve this data from web service 0. Okay, so we have also the second request, which is separately done without if you have stored data store and the instruction store, so we can retrieve directly this web service. Thanks, and if you have any questions.
Thank you for your presentation. if there is any questions.
Can I ask something about this approach?
Yes, yes, you
Yes.
can.
When we talk about to control big data, which are amount of data generated, for example, from sensors, etc., and they are required by some receiver, there is always the problem of not to give too much pressure on the receiver, and this means that there must be some protocol, some technique to avoid so many data to overwhelm the receiver. And I would understand in which way you control the amount of data to receivers. And also I would understand better because I have heard about the use of web services, but also I have, you mentioned the use of Golang, and this is for me interesting because it uses the CSP concurrent language with the synchronous channels. And
Yes.
so I would also ask you, when you talk about persistent channels, what are these persistent channels? They coincide with the Tonior synchronous channels between the two end part, receiver and sender. Thank you.
The persistent challenge is a form of threads which are
Yes.
a lightweight thread. We call it a green thread, and it have a small size in CPU. This small size is can grow on our needs, and instead of using store data on memory, then consume it by a threads. We schedule what we call a routine, which is a green thread, and on each data that is pushed in what we call a channel, the routine make its execution on it. So this I think for the first question, how can web services handle the amount of data? So we have a distributed architecture. So we can create a new instance if this overran the size of
There is a single receiver.
yes, the receivers. So we can create receivers as demand. We have one constraint that we need more hardware to handle it. More hardware to handle it. But if we have a great amount, we can handle it by creating a new instance of a receiver. So it's just an instance, and it is created as demand. If we can handle the amount of data by two web services, so we can create another to handle this to resolve this problem.
Okay, thank you.
I think Basil, we can move on to the next presenter.
Yes. Okay, the next presenter is B.M. Ahmed, presenting the barycentric Lagrange interpolation via Maclaurin polynomials for solving the second kind Volterra integral equations. Is she present?
Hello,
Hello?
can I hear
Yes.
me?
Yes, the floor is yours. You have 12 minutes to present.
Okay. Share screen now available to see it?
Yes, it is visible, yeah.
Okay. I present barycentric Lagrange interpolation matrix factor for polynomial for solving Volterra integral equation of the second kind. Outline, introduction, the presented computational method, computational results, and conclusion. What is the Volterra integral equation? U of x, the shape of Volterra integral equation, U of x equal f of x plus integral from 0 to x, k of x o t, u of t dt, where the f of x and the k of x o t are given functions. The u of x is unknown function and Volterra operator ku equal from 0 to infinity k of xu u of t dt. Volterra integral equation arise in several branches like scattering theory, potential theory, radiation, electromagnetism, and other fields. We present a new computational method for solving Volterra integral equation of the second kind, a modified formula of addition pericentric Lagrange interpolation established and applied for solving Volterra integral equation of the second kind. The main goal is improving the performance of traditional formula to minimize the round of error. For this goal, we expand each pericentric function into Maclaurin polynomial, so that is interpolate unknown function and the given data function and the kernel can be expressed through a monomial basis matrix. The proposed method consider Volterra integral equation of the second kind, phi of zeta equal eta of zeta, integral from alpha to zeta k of x to k of zeta t phi of t dt, where phi zeta b the n degree interpolate polynomial, phi bar n zeta equal x of zeta w u. To obtain a simpler matrix formula, we are now refining the pericentric Lagrange function by expanding them into Maclaurin polynomial to separate the monomial basis, as shown in equation number 4. Now substituting k bar from equation number 6 and phi bar from equation number 4 into right side of equation number 2, we get phi bar of zeta. Now let x bar be a square matrix as shown in equation number 8. Then equation number 7 becomes moreover by replacing phi bar defined by equation number 9 into 2, we get equation number 10, where the square matrix phi bar defined by equation number 11. Let LB equal phi of xi, thus we get the column matrix U by solving the system. To obtain a simplex matrix formula, we now refinding the pericentric Lagrange function by expanding them into Maclaurin polynomial to separate the monomial basis, as shown in equation number 13. In our paper, we study the convergence in mean and prove it in equation number 15. And the norm estimation, we study it and prove it in equation number 16. Computational results, we take example for polynomial kernel t minus x, as shown in example number 1, and compare between the exact solution and our interpolate solution. We get these results as shown in table 1. Phi of xi, that is exact solution,